prove a billions of years old universe? This is one that comes up all the time because people say, well, we know, we see the redshift, we see the background radiation, we certainly know that those stars are millions of light years away. And the answer is yes, they probably are. But does that prove the Earth is billions of years old? And that's a good question. That's one that creationists have struggled with for quite a while. There are a significant number of different answers to that question. The evolutionists have two. They have the Big Bang cosmology, which is based upon billions of years. So they're okay with that millions of years starlight. There's no problem for them. And they have the Big Bang, which exploded once, or is an eternal cycle of Big Bang, Big Crunch, Big Bang, Big Crunch. Okay? They're not clear which one of those works. But if it's Big Bang alone, they have a serious problem. Because they can't explain where the stuff originally came from. And that's a real big issue. You talk to evolutionary cosmologists, most of them say we don't know. Which I wish they would all make that confession, because then at least we have a place to begin talking with them about, well, then there must be something else beyond just the Big Bang. But let's go on from there. In terms of creation, there's three biblical explanations that make some semblance of sense. There have been more, but I'm going to focus on the three that I think make the most sense. One of them is that creation is mature. That when God made it in the beginning, He made it fully functioning just like Adam's body. So the stars were there, the light was transiting between them, everything was happening already, and God just brought it into existence, and there it is, boom. It exists on day number 4. He puts the planets and stars in space. Okay? That's a wonderful explanation, and that's got some drawbacks, and I'll come to it in a moment. The second is that the speed of light has decayed. Since we're basing our opinions, our measurements, on the speed of light being the unit to tell how far away those things are, if the speed of light has changed over time, those measurements are no good. And some creationists believe, and this is coming back into popularity, surprisingly. Some of the work that Barry Setterfield has now come back in the secular world is kind of surprising, because this runs in direct conflict with Einstein's theory of relativity. So there's all kinds of things there. But we also know Einstein's theory of relativity is not complete. Because if you read Stephen Hawking, who's the most brilliant mind in physics today, Stephen Hawking says that Einstein's not complete, Newton's not complete, there's got to be something else. And he's always tried to come up with something else and hasn't been able to at this point. He's worked most of his life on it, though. But let's say for a moment this were true. What this would say here is that in the beginning the speed of light was almost infinite. And then over time it came down to this slow, 186,000 miles a second is not slow, okay? But it came to this much lower level. That would mean the stars are really not hundreds of millions of light years away, but only thousands or hundreds of years away, even at great distances. The problem with that theory is it can be measured. We could figure out if that's true, but it'll take a couple thousand years to do it. And none of us are going to be here a couple thousand years to see those measurements. So that's a great theory. It may be true, but there's no way to really test it. Okay? The mature creation theory does suffer from a series of flaws. And the most common one is this, that we'll see every once in a while a star that's 100 million light years away novate. The star explodes. And we witness that. Now that light left that star 100 million years ago, theoretically. If that's true, then has God lied to us? Because that event never took place. So there's a question there about how that works, and a lot of creationists say that really doesn't fit us. So let's go to the third one. The third one's a little technical. It'll take a minute or two to explain it. And I know some of you will not stay with me, but that's okay. If you get questions later on, come back and we can talk about it. Okay, first of all, gravity distorts time. We know this. If you get more intense gravitational effect, the clock slows down. Now, that's hard for us to comprehend because we're creatures trapped in time. It's difficult for us to grasp how does gravity distort time. We know that that's true because we've tested that. And Einstein's relativity speaks to that, says that gravity distorts time. We know it's true, at least partially, because we've got an atomic clock at sea level in England. And we've got an atomic clock about a mile high in Denver, Colorado. And we look at those clocks each year and see a couple microseconds different. And the clock closer to the Earth's gravitational center is a little bit slower than the clock that's above it. Astronauts in space have taken atomic clocks with them and found that those clocks, in fact, do run slower when they're in Earth orbit than when they are on the surface of the planet. So it would appear that, in fact, that's true that gravity does distort time. If that's true, then, where the center of gravity is, the clock runs slowest. Just hold that thought for a moment, okay? Einstein's theory also implies that time had a beginning, and of course that creates problems for evolution because evolution has to be an eternal cycle. Time cannot have a beginning if evolution is true. Because if time had a beginning, you need a primary start to time, and you have to postulate something else. And you've come immediately to the concept of God. And time is relative, not absolute, in Einstein's system. Okay, that's Einstein's relative. You can take Einstein's model, and you can use it's really just a set of mathematical equations. You can take that model, and you can create a Big Bang. You can take the universe and bring it back, if you will, because it's expanding now. Bring it back to the point where it's just a tiny little ball in the beginning. But in order to do that with Einstein's relativity, you've got to set some parameters inside the equations. And these are the parameters you have to set. The universe has no boundaries. It's infinite, not finite. It doesn't have limits. It has no edge. It has no center of mass. It has an even distribution of matter. I'll come back to that in a second. And there's no net gravity effect. Since it has no center and no center of mass, it has no gravity effect. That is, time is not affected by the gravity within the context of the whole universe. Well, Dr. Russell Humphreys at Sandia Labs in New Mexico looked at this and said, wait a minute. Based on our observations of astronomy, most astronomers are coming to the conclusion the universe probably does have boundaries. It probably is finite. It probably has some form of an edge. It probably has a center of mass. The distribution of matter, observationally, looking out at night at the sky, is clearly non-uniform. And the universe is full of lumps and bumps. It's not an even distribution of matter. There's great walls of galaxies. There's galaxies over here. The North Sky has almost no material in it. There's a whole myriad of different bumps in there that are non-uniform. And if you set these as center of mass and set these other parameters, and you run Einstein's theory, you don't get a Big Bang. You get something called a white hole explosion. And when you get that, here's what happens. The clock runs slowest here. 24 hours here is 100 million years at the fringe of the universe.
Oh, wow.
So you can see the stars. I'm not going to spend any time on this. Just to those of you that are technical, these are the differences between the two. One throws out light, one pushes in light. I'm just going to leave that there for a second to just let you take a look at it. But let's look at the picture, okay? The picture is simply this. On the earth, on the fourth day, when God begins the creation, because of the shape of the universe, and this gets a little more technical, and if you take a look at the video sometime, Starlight and Time, maybe we'll do that in one session, you'll see the picture. But the clocks run slowly. This is 1 day, and this is billions of years at the fringe of the universe. You can see that light from the stars, even though only 1 day has transpired on the earth. Now that's amazing stuff, because that puts in context for us the ability to comprehend how the universe could be old and still be young and still look old.